Let's read the description of this question. Duplicate zeros. As you say, given a fixed length of integer array L. A fixed length means the length can be changed after it is given as input data, and we need to duplicate each occurrence of zero. Duplicate means we need to copy twice when we meet zero, and shifting the remaining element to the right because the zero occupied more space, and we need to shift the remaining element to the right. And the element beyond the length of the original array are not written. That means it needs to be trimmed off to cut it the end of them, and do the above modification to the input array in place. In place means we only change itself and do not return anything. Means we can't create a new empty list, we just modify itself. Let's see the example. Example 1. After calling a function, the input array is modified to this, so we only need to change itself. After calling your function, the input array is modified to. You select the meaning. And the constraint says the length of the array should greater than or equal to 1, less than or equal to 10,000, and the element inside the array is greater than or equal to 0, less than or equal to 9. This means single digit, unit digit. As this program demands, the array should be modified in place. But if in place was not a constraint, we might have just copied the elements from a source array to a destination array. As the statement also mentioned, we do not grow a new array. Rather, we just trim it to its original array's length. This means we have to discard some elements from the end of the array. But these elements, the new indices, are beyond the length of the original array. So these extraneous elements shouldn't be trimmed. We find an array here. The array here is apparently a source array. Source array here as an input, and we need to get a destination array. This is what we want to get, and we need to initialize the index of the source array to 0, and the index of the destination array is also 0. And then they start to perform this duplicated process. For s in range n, and n is the length of the source array, and when we meet 0 means if source at s equal to 0, and then that means destination at d also need to get the 0, and we need to copy. So we need to set the neighborhood adjacent at the right neighborhood also to 0, right? So we just incremented 1 and perform again. So its neighborhood is also become 0, and then else if it is not 0, then we just destination at d just get the value from the source at s, and outside if statement the d index is just incremented. So we finish. This is how the duplicated 0 performed. Remember the problem constraint that we are given. Since we can't use extra space, our source and destination array, essentially they are the same. And we can't just go about copying the source into the destination array in the same way. If we do that, we would lose some element, since we would overwriting the array. If we just copy 0 twice, we would lose 2, unless we first copy 2 further ahead. So here, I will use two-pass approach. It just costs O of 1 space complexity. Intuitively, if we know the number of elements, which element would be discarded from the end of the array, then we can copy the rest. But how do we find out how many elements would be discarded in the end? The number would be equal to the number of extra 0, which would be added to the array. And the extra 0 would create space for itself by pushing out an element by one element from the end of the array. Once we know how many elements from the original array would be part of the final array, we can just start copying from the end to the beginning. Copying from the end will ensure we don't lose any element, since the last extraneous element can be overwritten. Let's try to build it into your algorithm. Find the number of 0 that would be duplicated. Let's call it possible underscore loops. We do need to make sure we are not counting the trimmed of zeros, since the discarded 0 wouldn't be the part of the final array. Duplicate zeros, hence 2 elements in the end are discarded to create for our space. And the count of possible underscore loops would give us the numbers of elements that would be trimmed of the original array. Hence, at any point, length underscore minus possible underscore loops is the numbers of the element that will be included in the final array. And I should mention, in the diagram here, we just show the source and the destination array just for you to understand our purpose. But in reality, we will do these operations only on one array. Let's talk about the edge case of this problem. Handle the edge case for when a 0 present on the boundary of leftover element. We need to be extra careful when we are duplicating 0 in the leftover array. This care should be taken for the 0 which is lying on the boundary, since this 0 may be counted as with possible duplicates, or maybe just got included in the leftover when there was no space left to accommodate its duplicates. If it's part of the possible juice, we would want to duplicate it. Otherwise, we won't. Let's iterate the array from the end. We copy a non-zero element once and copy a 0 element twice. For discard the extraneous element, we start from the left of extraneous element and start overwriting them with new value. Copy element to the left of discarded element. For example, we just overwrite 4 here. It is because we have already copied 4. And eventually, we right-shifting the leftover element and creating space for all the duplicated elements in the array. Final array with duplicated is formed by modifying existing array. By using 2-pointer, we're just simulating the copy from source to the destination array algorithm, but in the reverse direction. First, we have array, and as input, and inside is a list element. And we need to initialize first, give them declare a variable possible underscore loops is a 0, and the length underscore is length of the array -1, and the left is a 0. Left pointer is a start from 0, and let's get started. So first we need to count the 0. If array at left pointer is 0. That means we meet 0. Possible underscore dupes increment 1, and this is inside a for loop for left pointer in range length underscore +1. So this is 8, and they will loop in the array, and the if statement is inside for loop. And we can make an experiment by print possible underscore dupes. Yeah, it shows it is 4, and if it is this, it is 3. But there are 3 0, but the third 0 was trimmed, so we need to add a if statement before to break out the program. If left greater than length underscore minus possible underscore dupes, then it will break. This means it reached a boundary. After it reached a boundary, it will break. So the third one will never be counted. So let's run again. We get 2, so only the first 0 and second 0 will be counted. And we need to consider the edge case. The edge case is this. There will 3 0 be counted, but as we showed before, the third 0 should also only copy 1 time, not copy 2 times. So we need to consider the edge case. If left is equal to length underscore minus possible underscore dupes, that means it's exactly on the boundary. So this time the array at length is become 0, and we just include it, but without copy, and the length underscore is decremented 1, and break. So the answer become 2. Only the first one, second one will copy. The third one will copy 1 time, and the first and the second one will copy 2 times. So we finished how to count a 0, and we can delete this test. And now we need to copy the 0, because we know how many 0 should be copied, right? Should be duplicated. If array at I is equal to 0, this means we meet a 0. The array at I index plus possible dupes. This means right shift possible dupes is also become 0. And the possible dupes decremented 1 because we just copied 1 time, so it need to decremented 1, and we need to copy it again. So this time the left neighborhood, the left adjacent to this index array is also become 0. So it is copied 2 times, right? So else if it is not 0, then just copy itself. Array at I plus possible underscore dupes right shift and equal and is also copied to array at I. So it just copies itself and redshift. And this statement is in a for loop for I in range, the last element to 0, and decrement 1 at each iteration. And this if statement is inside the for loop, and we need to declare a last variable. It is the length underscore minus possible underscore dupes. This is the last element. We always run this for loop from the last element to the start, and so we are done. We can define a function. Define duplicate zeros self array as an input, and it is a list, and inside it is an integer as an input, but return none, and give them a indentation and class solution, and also give them a indentation to make sure the function is inside the class, and we can print out. So the array 1 is this, and then we can do the function solution dot duplicate 0 array 1 and print array 1. Yeah, here we go. We duplicate the 0 and trim the what behind it, and we can also give them like array 2 as an example, and the solution dot duplicates array 2 print array 2, and it also duplicate 0, and here we go, we are done. Let's analyze complexity. The first is the time complexity is O of n, while n is the number of elements in the array, like the length of the array for these two cases it is 8 elements in the array, and we do two passes through the array. The first pass is to find the number of the entire number of the possible array, and the second one is to copy the elements. So in the worst case, we might iterate through the entire array, like when there is less or non-zero in the array. And about space complexity is just easy. It's O of 1, because we don't use any extra space. We just replace itself in place.